Hello, today we are going to talk about Unit 1, Lessons 14 and 15, Transformations 1 and 2. And we went ahead and just put these together because they flow really nicely together. And so this will go for 1.14 quiz and 1.15 quiz. So let's go ahead and look at your student objectives. Students will be able to translate geometry language to common language. Oh, I see that I have a typo right there. I'll fix it real fast. Okay, determine the difference between each transformation. That's talking about rotations, reflections, translations, and identify each transformation visually. Okay, so the first one we're going to start out with is a reflection. Okay, reflection, it's just like a mirror. So if you see down here, let me go ahead and get my pen ready. If you see down here, I've got a little note that talks about what it is. It's just like a mirror. So when you're standing in front of the mirror and you see yourself, you stay the same size, but everything's just being flipped. So like your left becomes your right becomes your left. It's just all kind of flipped on you. Okay, so you can see here how we start with a pre-image. It takes the transformation, so it's being reflected, and then you get an image, okay? So the pre-image is what you start out with, and then it turns into an image. To denote an image, we use these little tick marks up here, okay? And we call that prime. So that would be A prime, B prime, and C prime. Okay, and remember, we're not moving it or making it bigger or smaller. It's staying the same size. We are just flipping it. Okay, let's look at another one. Rotation. Okay, so just like a mirror. Oh, no, I don't know why I have that in there. Let me take that out real fast. I forgot to take that out. Okay, so the object, it still remains the same size. It's just being turned now. Okay, so that's what rotation is. We're just taking it and we're turning it. Okay, so the image, so remember what we talked about just a minute ago, the image doesn't have the prime symbols. So this one is your first image. Okay, then it was rotated counterclockwise and we got our image, or the second image, and we know it's the second image because it's got the prime marks. Okay, so then what we can do to kind of take a look, so like we've pulled out two side lengths, so AB side length and then A prime B prime side length, and so we can compare that they stayed the same size, we just rotated them. Okay, so let's look at another one. The next one is a translation. Again, the object remains the same size. You're just sliding it. And sometimes when you're dealing with translation, it'll tell you like, instead of just sliding it diagonally like this, it might tell you to slide it to the right and then slide it down. Okay, you can slide it twice, being a translation. Okay, you can slide it 3 times, 4 times, 5, you can just keep sliding it all over. Okay, each time you slide, it's going to change the way that you mark it. So let's say if this was our pre-image, okay, so this is the first one we start with, and then we went to this one, this would be your second image, so we would denote it with a prime. Okay, if we go ahead and do this, if we took this image and moved it this way, okay, that would then be our next image. Okay, so let's draw another. Okay, then it's this corner, it stays right here. It still stays A, but now it's a double prime. So this is the second image, and then this is the third image. Okay, so do you see how all that sliding can all take place? It's very different. Okay, so then now let's talk about being isometric. Isometric transformations, that's the 3 that I just talked about. They map congruent figures to each other, and they keep the same size. Okay, this is the key thing about being isometric. They keep the same size. So you can see right here on all this mapping that we did. Okay, first we start out with our pre-image. It's the one that doesn't have any tick marks. and then we map it the first time. So then it goes to this one. Then we map it, we've got 2 primes here, so it goes to this one. Then we could map it back to the exact same location, and those would have to get 3 tick marks, that image would. Okay, so the pre-image starts it, has no tick marks, then you add a tick mark each time you map it. Okay, so now let's look at geometry language versus common language. Okay, and this is going to come up really important when you take your 115 quiz. Okay, so in geometry we say we rotate it. Well, all that means in common language is that you're going to turn it. So if they talk about turning anything, you need to think rotation. Translation, they'll say slide. Sometimes they might just say move, if you move the figure. Okay, and then reflection, the common language for it will be flip. Okay, so look for those 3 terms in their common language. Okay, so let's look at this example. We have a pre-image and then we have the reflected image. It says Sam flips an image from one side of a line to another. This would be an example of, okay, the answer there would be reflection. Next example, Sam moves an image to the right 5 inches and down 6 inches. This would be an example of translation. Next example, Sam turns an image around a clock dial. This would be an example of rotation. Okay, and lastly, we have a special note. Anytime you apply a transformation, you are not changing the size of the object. That goes for all 3 transformations: rotation, translation, reflection. Okay? When you use those 3, you are not changing the size of the object. All right, guys, have a great day.